Now, while we're on the topic of heat, as I mentioned earlier, heat is a form of energy, and energy cannot be lost, but it can be transferred. A good example of this is when you consider a vehicle travelling along and then suddenly slams its brakes on. For example, when an aircraft lands and it puts its brakes on, they will heat up. Now, if it brakes too quickly, the brakes could actually set on fire because it's too hot. So that's vehicle travelling along, slams its brakes on, all that energy that it's had, got to be changed into something, it's changed into heat energy. Let's do an example of this. A petrol tanker with a mass of 16 tonnes, fully laden, is travelling at 60 kilometres an hour on level ground. Now the tanker carries out an emergency stop. How hot will the brakes be? It tells you the mass of the brakes on each wheel is 7.5 kilograms and the vehicle's got 10 wheels. The outside temperature, ambient temperature basically, is 5 degrees C, and the specific heat capacity of the metal brakes is 350 joules per kilo per Kelvin. Okay, so this is the information we've got there. So how would you determine the temperature of the brakes? Well, the question is asking you really to determine the kinetic energy that the vehicle possesses, work out the kinetic energy of the vehicle, and then convert all that energy into temperature, heat energy, into the brakes. That's what it's asking you to work out. So first of all, we need to determine the kinetic energy of the vehicle. And the kinetic energy of a vehicle is half mv squared, where K is the kinetic energy is in joules, the m is the mass in kilos, and v is the velocity in meters a second. Now you've got to make sure you've got all these in the right units. Now the mass is 16,000 kilos, the velocity is 60 kilometres an hour. Well, it's not kilometres an hour, we need to convert that to metres a second, which converts to 60,000 metres an hour. If you divide it out to make it seconds, it's 60 times 60. So 60,000 divided by 60 times 60 equals 16.67 metres a second. So that's the first thing you've got to do. Make sure everything's in the SI unit. And the SI unit is metres a second. 16.67 metres a second. If you put these in the formula, the kinetic energy of that vehicle is 2,223,111 joules of energy. So that's how much energy it is. Now all we need to do with that energy is convert it into heat energy and transfer it into the brakes. Well, the heat energy equals the mass times the specific heat capacity of the brakes times the temperature rise. Now we've got to make sure that they're all in the correct format. Now the mass of the brake drums is 10, there's 10 lots of wheels times 7.5, there's 75 kilos of energy. Well, that's right, isn't the weight mass, kilograms? If we put all those known values in, we get the energy equals 2,223,111 equals 75 times 350 times the temperature rise. Therefore, if we transpose this, the temperature rise equals 2,223,111 divided by 75 times 350, it gives you an 84 degrees C rise. That's your temperature rise. That's how much heat they would heat up by, 84 degrees. Now, the ambient temperature was 5 degrees, so the temperature of the brakes should be 89 degrees C. That's how you do it. You convert all the kinetic energy into heat energy and divide that by the mass times the specific heat capacity of the brakes. Now, if we did check those brakes, they would not be that. They would not be that hot. Why? Well, not all the kinetic energy will be converted to heat energy because you lose some to air resistance, the back plate heating up, and there's air around the brakes would take heat away. In other words, it's not 100% efficient. However, there would be roughly that. They would be very, very hot because you've slammed the brakes on.